So I'd like to introduce Dr. Katharine Mach. Before introducing her, so she works for Stanford. She leads a environmental assessment unit there. But I was going over her resume. I was so impressed, and I feel like my work is really worthless because she's leading the world in making a global advance in the not only in research but implementing action. So I'm really honored to introduce you, Dr. Mach. Your work is impressive, is an inspiration for everybody. So having you leading us globally on IPCC, and it's an honor to have you here. Thank you.
Great. It's really an honor to be here today. Thank you so much. For the last report from the Intergovernmental Panel on Climate Change, I directed science, in particular the part of the IPCC that focuses on risks in a changing climate and how we can prepare for them. That report was called Climate Change 2014, and it was a really exciting report to work on, not just because it was 300 of the top scientists from around the world across all relevant disciplines, but also because it was the report that provided the scientific basis for negotiation of the Paris Agreement, something that I and many other scientists in that report participated in really extensively. But 2014 was a while ago. So instead of discussing that report, which was called Climate Change 2014, I'm going to zoom forward to the present. I'll walk through a lot of the key conclusions on what the problem of a changing climate looks like, how to think about the space of solutions. But where science has advanced or society has changed profoundly, I'll also make reference to those dimensions. A big evolution in thinking about the climate challenge in research on it and also in assessment has been an increasing focus on risk. A focus on the fact that responding to the climate challenge is all about understanding, managing, and reducing risks. I think Jack's example of getting on an airplane is exactly that type of probabilistic thinking that is relevant. We know the odds of many different outcomes are changing. But when we think about risk in a changing climate, key lesson number one is that it's not just about the climate. Risk here in the center of different climate change impacts indeed does involve the climate, the hazards, the sharp end of the climate system, whether it's a heat wave, a flood, or a drought. But that climate event in isolation isn't enough to give us damages that matter. It's how the climate intersects with people, societies, economies, and nature, which are vulnerable and exposed in different ways. Against this backdrop of risk, as we've heard so eloquently so far, the odds are changing. We see unequivocal warming up to 1 degree Celsius now at present. Jumping back to the last IPCC assessment report, it was the first one that could take a deeply comprehensive look at impacts that are already happening. And what do we see across a vast body of research and science and scholarship? It's that the climate changes that have already occurred have had widespread and consequential impacts that we can detect and attribute in a very rigorous way on every single continent, from the tropics to the poles, from the mountains to the sea. The method we developed in that last IPCC assessment report was able to tease out these types of impacts on every continent. Across the US, it's impacts, for example, in our forests, dieback, wildfire. Its impacts in our farmlands, impacts on agricultural production. Its impacts in cities, where we see unfolding extreme events having very complex impacts in interconnected systems, ranging from roads that are flooded to how that intersects with our communications and transport infrastructure. Where the science has zoomed forward in the last 4 years has really been the fact that we can now detect and attribute the role of our emissions of heat-trapping gases event by event. This is stepping out from super sophisticated science into the realm of pretty basic forecasting at this moment, where, for example, for Hurricane Harvey, there are already 3 papers out that have looked at how much more likely and severe that event was based on our emissions of heat-trapping gases to date. Against this backdrop of impacts happening in the world around us, though, what I'll emphasize one more time is that the people side of the risk equation really matters. The global attention on the climate issue has often focused on the most marginalized populations and the particular vulnerability, enhanced marginalization that comes from those circumstances. For example, these people are in a refugee camp in Sudan where they don't have the benefit of strong state capability, robust economies, or social safety nets to protect them if something happens on the weather side of the equation. But here in the US, I think what we have seen over the last year so profoundly is that wealth is not necessarily protection. There's unevenness of risk, and there's profound risk that unfolds, for example, whether it's cyclones or wildfires or drought all across the country. Stepping into the future, it's the last depressing part of the talk, then I'll get to solutions. What we see is that continued high emissions of heat-trapping gases really drive up the risks. The line from our assessment based on all of the evidence was that increasing magnitudes of warming increase the likelihood of impacts that are severe, pervasive, and in some important ways irreversible on human timescales. The assessment that we put together had the mandate of starting from all of the evidence that exists. For our report, that was 14,000 citations to the underlying primary literature. At the end of the process, though, our goal was to support negotiations of a temperature goal, along with policy in many other different ways. And we put together the evidence through two different approaches to assessment, key risks and reasons for concern. And I'll provide a bit of insight on the global scale assessment of why climate change matters, what we called 5 global scale reasons for concern. And there are 5 of them because values matter. There is no one way to measure what's at stake in a changing climate. Different people will have different legitimate perspectives on how important impacts are for the rich versus the poor, or the present versus the future, or nature versus economies. But across 5 very different definitions of risk, which I'll walk through in a second, what we see is that continued high emissions of heat-trapping gases take us across definitions of risk to those impacts that are severe, pervasive, and irreversible in the second half of this century and beyond if we don't change the course we're on. In terms of those 5 categories of risk, the first one is risks to unique and threatened systems. Jack set me up perfectly here. This is, for example, the impacts on Arctic sea ice, where we've seen profound warming and indigenous peoples dependent on those sea ice and ecosystems combined. Its impacts for coral reefs, where we have seen an unprecedented double whammy bleaching in the Great Barrier Reef over the last few years, where our emissions of heat-trapping gases made that temperature event 287 times more likely than it would have been in the absence of human-induced climate change. Second category of risk, sharp end of the climate system, the risks from extremes, heat waves, floods, droughts, where we've seen those profound advances that I mentioned in our ability to tease out our role in those events, event by event. The third category here, in many ways, is the one that I think of as the unfairness factor in a changing climate. The idea that when anything bad happens on the weather side of the equation, there will be winners and losers, some people who are profoundly more affected. We can think about that with the flooding events we have seen induced by cyclones over the past years, as well as monsoons, where if you're in a low-income country context, the deaths that occur are usually at least an order of magnitude greater than what you would get in a high-income country context. Next, you've got the aggregate impacts for the global economy as a whole, biodiversity overall, and the last one here is the potential for game changers, tipping points, irreversibilities in the climate system, such as the potential for very large amounts of sea level rise if the ice sheets tip in an irreversible sense. To give you a picture of what these reasons for concern look like in 2 images, they essentially span from this, the sharp end of the climate system, those risks from extremes, through to this, the potential for large-scale tipping points in our climate system in some very profound ways. Okay, the second half of the presentation, we'll talk about the space of solutions. And I think there are many reasons to actually be optimistic here in that responding to climate change in so many ways is a way to build a better world. Climate intersects with almost everything that we care about. I'll just highlight a few underpinning themes for this space of solutions. Number 1, this focus on risk carries straight through how we think about responses in many different ways. Something that is also quite compelling is that we see increasing momentum building in the space of climate change responses, and that's the case whether we think about clean energy deployments or the ways communities around the US and around the world as a whole are building their preparedness for different types of climatic events. And I think another point of optimism is the degree to which there are win-wins. Doing well in our climate responses often benefits society as a whole. On the science side of the solution space, I'm going to highlight two key features that I think are simple rules for thinking about the nature of the risks and responses unfolding ahead. What this first figure shows here, in the black squiggly line, the warming we've seen to date, about 1 degree Celsius temperature increase above pre-industrial levels. The red plume is a projection of warming with continued high emissions of heat-trapping gases. By contrast, in blue here, we see a scenario of very ambitious climate change mitigation, reining in our emissions of heat-trapping gases, keeping temperature at the end of the century below 2 degrees Celsius with a likely chance. Something we did that was a bit gutsy for the IPCC was that we highlighted some different eras in this space, and we called the first one the era of climate responsibility. The basic idea here is that over the next few decades, there is warming that is baked into the climate system. Due to our emissions to date, yes, but really importantly, due to the fact that we can't drop emissions to zero tomorrow, at least without crashing the global economy. We're going to need to prepare for those impacts that are in the pipeline, at the same time that these next few decades are pivotal for what we see in the longer-term era of climate options. Just to paint this one more way, this map, just pay attention to the colors right now, shows approximately the warming we've seen to date. Here now, at the end of the century, this is the additional warming that would occur. The color here is the same, the basic idea that in this world of very ambitious mitigation, we will still see one time yet again the warming we have already seen, and it will have more impacts than that last degree of warming that has been realized. By contrast, this world of continued high emissions that takes us with a good chance above 4 degrees Celsius temperature increase within this century pushes so many systems of the Earth outside of our bounds of historical experiences that it's actually very, very difficult to say exactly what will happen and when. This is a challenge of risk. Second key feature that I will highlight is the super simple way to think about the climate challenge. Now, most scientists like to highlight that this is really complex. It intersects with everything we care about. It's a wicked challenge, where wicked is a scientific term, believe it or not. But if you want to boil it down to a really simple relationship, this is one of them that can be helpful. On the y-axis here, we see emissions per person. On the x-axis here, we see GDP. Development economists will argue that GDP obviously is an imperfect metric of the well-being of societies, but is certainly one very important metric. The fact that this is a linear relationship on these log-log axes essentially points the fact to the societies that are highly developed in the world to date, that have high income per person, have gotten there on the basis of emissions of fossil fuels. When we have solved the climate challenge, this will be a flat line. That level of development will not be dependent on emissions of heat-trapping gases. So towards breaking this relationship, how are we doing? What this plot shows is emissions globally from fossil fuel and industry over the last decades. We saw an acceleration in the 2000s. Something really cool happened in 2014 to 2016. This is the first time in the history of the planet where the economy globally kept going up, but emissions flattened. That's exciting progress. But in terms of why that is not enough, I'm going to introduce one more concept, and that's the concept of a carbon budget. The basic idea here is that when we put carbon dioxide into the atmosphere, the warming from that CO2 is nearly permanent. As it drops slowly in its concentration in the atmosphere through time, the oceans become less able to take up heat. That gives us warming that is baked in over a very long time horizon. So if we set a goal, like limiting warming to 2 degrees Celsius, that permanent warming means that we've got a budget of how much CO2 we can put into the atmosphere. When we have finished up that budget, that's it. We need to be at net zero emissions at the global scale to keep warming stabilized. This brings us to one other very interesting way that science and the Paris Agreement intersected. What this schematic shows in an overly complicated way is emissions to date, and then an evaluation based on many hundreds of scenarios of what emissions might look like through the century to limit warming to 2 degrees Celsius. This essentially was the evidence basis for Article 4 in the Paris Agreement, peaking emissions as soon as possible, and driving towards a balance between sources and sinks in the second half of the century. What I'd like to highlight here is something where, again, the world has moved forward, in particular in the science, but also some interesting ways in the policy landscape. So everything here below the x-axis is what's called negative emissions. different ways of getting carbon dioxide out of the atmosphere. And what I would like to highlight in terms of keeping ambition on our climate responses really high in the near term is that this is a vast deployment of negative emissions that essentially expands the remaining available carbon budget. This scope of negative emissions, you can think of it, oftentimes you're using land, photosynthesis, and plants to get carbon out of the atmosphere, is way bigger than what we have achieved with agricultural historically. But in terms of kind of optimistic entry points in building experiences towards negative emissions, we've been doing work on things like the potential for bioenergy with carbon capture and storage, one way of getting carbon dioxide out of the atmosphere, through the only form of this technology that is profitable right now, putting carbon capture and storage on bioethanol refineries, building important experience that way. We've also looked at one of the few legally enforceable programs for increasing the amount of carbon stored in the land in existing forests. This one's only 5 million tons per year, but it provides some of the important lessons that we'll need moving forward. The last theme I'll highlight is that the Paris Agreement, yes, is an important marker in the landscape of climate responses, but action on the climate challenge is distributed. The Paris Agreement in some ways is just a starting point, a reflection for the world to consider that there is momentum at the international scale on this issue. But the real action is thinking about the different ways companies, communities, governments at subnational levels are coming together to drive forward solutions. There are a lot of reasons for hope that we should be proud of. Here in the US, we've been declining in our emissions at the same time that our economy has grown over the last decade. We see clean energy technologies surging in their deployments, and we need to find a pathway off of coal. Today in the US, more Americans die from air pollution from coal than there are remaining coal miners. This is a solvable problem in many ways. So what I will emphasize at the end here is that responding to climate change can be a way to build a better world, in particular if we're creative and ambitious. Thank you.